See. Okay, so did anybody get to play with the Sky Vector? Does anybody have any comments or questions about it?
Yeah, I played with it a little. It was pretty cool.
Not yet, however, I am looking forward to trying to map some stuff out this weekend.
Yeah, it's a lot of fun. Yeah, just to remind everybody, I won't be here tomorrow. Adam's going to be running the show tomorrow. I'm hoping to use my flight benefits to sit up in the cockpit and get some jump seat time. So we'll see how that goes.
Where are you going?
Probably to Salt Lake, but I might go the long way into Salt Lake. I'm thinking about going into Phoenix and then from Phoenix up to Salt Lake. So
Nice. I might do New York this weekend.
nice. What do you do at SkyWest again?
I work in maintenance safety.
Okay, that's right. Yeah, I'm pretty excited.
Looking at the flights out of Vegas, it's like 110 seats out and 120 back. That's crazy.
Yeah, that would probably be a fun one. I got to get to Salt Lake because I got some family stuff going on there, but we'll see how it goes. We'll see. Basically, I got to find any way I can to get up there. So, all right. So today we're going to continue.
Jared, in playing with Sky Vector, I was experiencing the same problem you did, is where it puts you in another country or continent. And I noticed that it doesn't when I have my mouse depressed and I pick my mouse up.
Oh, really?
So then I end up in Africa or Greenland or something like that.
That's always exciting, huh? Yeah, I don't know what was going on yesterday. I've got a Mac, like I said before, and so the mouse, it'll sometimes just kind of twitch out when I put another finger on there, or I'll accidentally swipe and move the screen, or I don't know, it's just kind of weird. So I'm sure it was me doing something, but yeah. So yeah, Sky Vector, pretty cool tool. We're gonna keep using it. So yesterday I was telling you guys about the terminal procedures, your instrument approach charts. We kind of took a look and saw where those are, where we could find them, and we did like a really, really, really brief overview of what they were. Today we're going to talk a little more in depth about the information on those charts, and we might play around with a couple just to get you guys a little more familiar with Sky Vector, start warming you guys up with it. So terminal procedures. What area do we consider terminal again? Does anybody know?
I just put terminal VOR 25 nautical miles.
Yeah, so it's going to be the areas around the airport, right? Around these airports. So we're going to talk about alternate minimums, departure procedures, and the arrival standard departures and arrivals. So let's see. So the outline we're we're going to talk about takeoff minimums and landing minimums, and then our alternate minimums. When do we require an alternate?
Always, unless 1, 2, 3.
Yeah. So 1 hour before, 1 hour after, 2,000-foot ceilings, and 3 miles of visibility, right? What happens a lot of times is people get mixed up between our landing minimums and our alternate minimums, and they start applying the 1, 2, 3 rule to our landing minimums, and that would make a lot of airports illegal to go. Like, we would not be able to fly if our alternate minimums were our landing minimums, or if we were applying the 1, 2, 3 rule to our legal to go. So departure procedures, we'll talk about those. The NACO charts, so National Aeronautics Charting Office. So we're largely going to be using those. We'll look at the Jeppesen charts as well. And then the same for our stars. So NACO and Jeppesen are the two companies that create a lot of our charts for our instrument approach procedures or our arrival and departures. And what these charts do is they help air traffic control. They basically really take a lot of the burden of traffic off the air traffic controllers, because it's a planned route that all the pilots, will use to get out of the terminal area. So those areas that are just really highly congested and just really busy, it just relieves a lot of that workload and pressure off the air traffic controllers. So they're safer and more efficient. They actually publish these into booklets that you can buy, but the problem with buying the booklets is you have to update. You have to buy the new one like every 3 months. It's a really good way to a really good business model. Make a chart mandatory and then update it every 3 months so that everybody has to buy that chart every 3 months, and it costs the same regardless of when it is or what changes had to be made. That's a really good business model. It's a kind of a monopoly, right? Government's really good at it. TPP. So these have our departures, takeoff minimums, our stars, instrument approach procedures, and our airport diagrams. So departure and takeoff minimums. So when we're talking about takeoff minimums, once again, before we look at that, when do we require an alternate for our departure? A departure alternate.
Wouldn't it be if you're below minimums?
Yeah. So if our departure airport is below takeoff or landing minimums, or if the airport has published takeoff minimums, it's going to require us to file an alternate takeoff airport. So let's see, takeoff minimums are lower than landing minimums. Why would that be?
Because once you land on the ground, it's easier to take off than it is to land in bad weather.
Yeah, so takeoff, we just basically have to see what's right in front of us, right? We got to see the runway. And just keep the airplane on the center line. After that, we're free and clear. Takeoff minimums, a lot of it has to do with our visibility. Ceiling minimums are only included for see and avoid obstacles. So see and avoid obstacles would be things like radio towers or trees or mountains that are in the path of the departure. Published takeoff minimums. So we've got the FAR's standard takeoff minimums. We've got FAR's non-standard takeoff minimums. And then basically what this is saying is that based on our op specs as an air carrier, we can have our own deviations or exemptions to the FAR minimums that they require. Does that make sense?
Yeah.
You guys see how this is just kind of building on the FARs that we went over, right? So the FARs, if we were Part 91, our standard minimums would be 1,003, right? But based on our operation specifications that the FAA has approved, we are exempt from that, and we can use the landing minimums as our takeoff minimums. And it can actually even go lower than that. We can use, depending on the authorizations from the FAA, we can actually use Cat 2 approaches, Category 2 approaches, or Category 3 approaches, depending on the equipment and training we've provided our pilots. So, and if we've been approved by the FAA. Landing minimums, the visibility in 121, we may need to file a departure alternate if the takeoff, with, that is worded so weird. Basically what it's trying to say is what we've already said is if it's below minimums, then we need that departure alternate. So published landing minimums, we're going to look at our instrument approach procedures to get those minimums. So let's dive a little deeper into visibility, okay? RVR, do you guys remember when it was like the first or second day? It was probably the second day when we kind of touched on what RVR was. You guys remember?
Runway visual range.
Right. So do you guys remember how they determine RVR?
Yeah, you shoot a laser down the runway.
Yeah. So there's basically 3 stations on the side of the runway where they'll shoot a laser from the end of the runway to the middle of the runway, and then from the middle of the runway to the other end of the runway. And that's going to give us our visibility in feet from those stations. So if there's an obstruction, whether that be haze or fog or mist, it's going to tell us how far that laser is penetrating before it's basically not visible anymore. And it's going to publish that on our weather reports and tell us what the visibility is at that point in time when they took that measurement for our runway. So it's in hundreds of feet. Okay. This is a standard. If it were metric, it would be in meters, right? This would be in meters. This would be in meters. But in the US, we use feet. Okay. Horizontal distance from the approach end. Oh my goodness. So moving aircraft based on high intensity runway lights or visual contrast of targets. The visibility is updated every minute. So there's up to 3 transmission. I don't even know how to say that. Transmission meters. Goodness sakes. So, like I said, the touchdown, midpoint, and rollout of our runway. So the way we'd see it forecast is typically we'd see it on our METAR, and we'd see like a 1600 or something of that point, or we'd see, like it says here, 555. And that's just saying that from the touchdown to the midpoint, 500 feet, midpoint out 500 feet, and the rollout would be 500 feet of visibility. So each one of those stations is reporting that there's only 500 feet of visibility. So RVR is controlling. So what that's saying is we can look at a weather forecast, and on our weather forecast, it could say that we have a quarter mile of visibility. But then we could look at our RVR, our current RVR that's reporting on that runway. And if it says 2,400 feet and our landing visibility minimum is 1/2 mile, that RVR report overrides the forecasted report. Does that make sense? So it would technically be legal at that point to land on. So does anybody have any questions on that? I mean, I need to make sure you guys all understand that.
I understand it.
Okay. Does anybody have any questions on that?
Yeah. What's the SM under visibility?
So that's statute miles. So we've got nautical miles and statute miles. Your forecasts are going to report in statute miles of visibility. Kind of wish they just, switch to the metric system and everything was universal rather than having to switch back and forth between nautical miles and statute miles and feet and meters. But
yeah, I'm glad SkyWest only flies domestic.
Yeah, but what's funny is we actually fly to Canada and Nassau, Bahamas as domestic, and both of those areas will report in meters. So,
yikes.
Yeah, so you got to be on your toes and really know where you're sending these aircraft. So. So that RVR is controlling can also work the other way. Say our weather forecast is reporting a 1/2 mile, so we're at our minimums, but our RVR is reporting 500 or 1600. Even though our forecast says that we're at 1/2 mile, if we get an RVR report that says that we're below that, then it's not legal to land at that airport. So this is a little tricky to learn and apply. So I hope you guys understand that. And if you guys have any questions, let me know. So RVV, okay, this is the horizontal distance. We see unlighted objects. So this is also using, huh?
Do you want us to write any of this down?
What was that?
Do you want us to write any of this down?
Well, just kind of take notes. I'm not going to make you write these things down. And if you have to, like if you're going to be tested on it, I'm going to let you know. But at the same time, I want you to remember like RVR is in feet and it's a conversion from our, and from statute miles to feet, and it's actual visual on down the runway, and that it's controlling. So regardless of what our forecast says, our RVR is what is controlling. Hold on, sorry about that. So, prevailing visibility. So RVV is used in lieu of prevailing visibility, right? Horizontal distance. A lot of these we don't really even use. Tower can report visibility, but we're going to use RVR, or forecasted visibility. So we'll just kind of run over these really quick. So the horizontal distance, objects, bright lights identified at least 50% of the horizon. So you can identify those. Statute miles are fractions of miles measured from the control tower. Tower visibility is visibility determined from multiple points. Control tower observation is the tower visibility. A lot of times, I don't think that the tower's really going to report, tower visibility to you. If a pilot is requesting visibility from the controller is going to give him RVR. So the only time I see, tower visibility coming into play is when it's like a smaller airport and they don't have RVR capability. So so the FAR standby takeoff minimums. It depends on, depends on the number of engines. It also depends on any of your exemptions, right? You guys can see that. So for non-standard takeoff minimums, which we use, so this is for standard takeoff. We're going to talk about non-standard takeoff minimums, which we are going to use. Published in the TPP. So higher than standard, and some departures allow a departure with standard minimums provided the aircraft performance requirements are met. So we're going to see this in our operation specifications. It defines authorizations, limitations, and procedures based on the type of operation, equipment, and crew qualifications, like I had mentioned before. So if you want to do Category 3 type landings, you have to have this. This is one of the requirements, is having a heads-up display and auto land capabilities. You guys saw the Category 2 landing. Category 3, basically they don't see the runway until they're on top of it. It's pretty scary. So our op specs are extension of the FARs, the legal contract with the carrier. We've kind of beat that one to death, haven't we? Our op specs are authorized by the FAA and work in conjunction with FAA regulations. So they provide operational limitations and procedures, required equipment and crew training, and allow lower than standard takeoff minimums, low as 300 RVR with heads-up guidance system, and that would be considered a Category 3 landing. Let's see. So in the Jeppesen charts, we will have a page in the JEP charts for an airport that will give us alternate takeoff minimums that we'll take a look at. Op specs, we can only go as low as the op specs. So SkyWest RVR, this needs to be updated. SkyWest RVR is 600, 600, and 600 now. So we'll probably use 500, 500, and 500 in this class. Does everybody see where I'm seeing that?
Yeah, I see it.
Okay, so SkyWest, we use 600, 600, and 600. And that's for our takeoff. That's for our takeoff. But we'll probably just use 500, 500, and 500 in this class because it's a nice, easy, round number. So we need adequate visual reference still. We can still depart as long as we don't have equipment out of service. And the takeoff surface continuously identified directional control takeoff run. So that's just saying you have to be able to see the runway passing underneath you, right? The visual aids that help us help the pilots stay on the runway is you have these high intensity runway lights and your center line lights marking the center line where the center line is. So every time you go flying as a pilot, that's what you're trying to stay on, is you're trying to keep that nose wheel right on the center line of the runway. And that just keeps you safe. That keeps your wings clear on the sides of the runway and things of that nature. So, and then there's other runway markings. You know, you have your touchdown zone lights, you got your, approach lights, things like that will help us maintain that visual where we are on the runway. So this is what our takeoff minimums look like on a Jeppesen chart. We call them JEP charts. So notice that the standard minimum visibility is equivalent to 1 mile. So here's your standard, right? For 1 and 2 engines. And half a mile for 3 or more engines. So this is the way we read these charts, is we'll go to the runway that we're going to be going down. We've got runway 7 left and runway 25 right. And then we have runway 7 right, 16, 25 left, 3, 4 on this side, and it's separated by a bold black line. This will tell us our adequate visual reference, but this gives us our standard for that departure. And then we can look over here and see the category of aircraft or the amount of engines that it requires. As you can see on this side, for filing as an alternate A, B, C, and D, a little different from our takeoff alternate. But basically it divides the category of aircraft and where the requirements are different. So 1 to 2 engines, RVR 5,000. We're going to add 2 zeros to that number, or 1 mile. So that's what they determined the RVR value is relative to a mile. But we know that a mile is more than 5,000 feet, right? So that's why RVR kind of helps us out. It gives us a little bit of a cushion, I guess you could say. 3 and 4 engines, your RVR is basically cut in half. So then if we're departing from these runways, what would our standard be? At what point would we require a takeoff alternate?
When the weather gets below minimum.
Okay. And what would let's say it's 7 right that we're using. What would the minimums be?
Standard
So you mean-
visibility is 1 mile.
So you mean in terms of RVR or 50 instead of the 1 mile?
For 7 right.
Where it's below,
For 7 right.
below 50.
Right. Remember that so 7 right, we're going to be looking at this box, right? And we're going to look and see how many engines. But for 1 and 2, 3 and 4, it's going to be the same when we're looking in this box. So what is that saying? What would our minimums be?
301 mile.
Yeah, so this one would be 300 feet, 300-foot ceilings, and 1 mile of visibility. So this one doesn't have a ceiling requirement. This one does. Okay. So departure alternates. So whether to take off below landing minimums must have a departure alternate airport. For emergencies, you can't land it at the departure runway, like we talked about. So for an aircraft having 2 engines, what requires us to have that alternate departure alternate airport would be what again?
It's not a departure takeoff, just a regular departure airport.
Well, the departure alternate. So what would require us, or takeoff alternate, departure alternate, those words are interchangeable. So, nope. So that's for a destination alternate.
Yeah, weather minimums.
Okay. So what's required? How far can that departure alternate be?
Oh,
it has to be,
less than an hour from the destination airport.
Yep.
Or the takeoff airport.
What are the other requirements too that go along with that?
in still air
yeah.
with 1 engine in op.
Right. Okay. Perfect. So it requires us to have an alternate within an hour at normal cruise in still air with 1 engine inoperative. Destination alternate, like we said before, like I just said, the 1, 2, 3 only 1, 2, 3 rule only applies to our destination alternate. And it only applies to our first destination alternate. We can have up to 2 destination alternates, but our destination alternate is the only one that we can apply that 1, 2, 3 rule to. It's the only one that we want to apply the 1, 2, 3 rule to. So the second destination alternate, we'd have to have the times that we require a second destination alternate would be when there's marginal weather at our initial destination alternate. Okay. Let me rephrase that. So when we have marginal weather at our destination and our first alternate, it requires that we have a second destination alternate. Super confusing, but I'm going to define what marginal weather means, so I want you to write this down.
Marginal weather?
Yeah, so marginal weather, I'm going to define it for you right now. Marginal weather is when at the destination and at the first alternate we are at landing minimums. And I'll explain that to you in just a second here. So marginal weather is when at the destination and at the first alternate we have landing minimums. I should say the weather is at landing minimums. That's what it is. Not we have landing minimums. The weather is at landing minimums.
Sorry to repeat one more time. So what's the term? I got the definition down.
Okay. So marginal weather.
Marginal weather. Okay.
Yep. Look at the screen here. Marginal weather is when at the destination and at the first alternate, the weather is at landing minimums. It's hard to get a TAF that. Let me take a look at see if I can find something. Okay, let's see if I can find us some amazing weather here. Okay. So it's actually looking all right up there. Anyways, so let's say that in Seattle, our landing minimums were 200-foot ceilings and a half-mile of visibility. Actually, let's see if I'll just make a Word doc here. Oops. So 200 foot and a half-mile viz. Okay, so this is Seattle. Right, and our alternate airport was Portland, and their landing minimums are 200 feet and 1/2 mile viz as well. So we talked about alternate minimums a little bit when we were going through FARs. And we talked about the 1 nav-aid, 2 nav-aid rule. Does anybody remember what that is?
Yeah, the 1 nav-aid rule is that would be 400 feet ceiling and 1 mile visibility, and the 2 nav-aid is 200 feet ceiling and 1/2 mile visibility.
Yep. So we're gonna, the lower of the two, let's say that Portland, it's alternate minimums. Let's say, so we're gonna say that they fall under that 2 alternate rule, or 2 nav-aid rule. What would their alternate minimums be at that point? What's the best alternate minimums we can get?
400 foot ceiling and 1 mile visibility.
Perfect. Okay. So let's say that we take a look at our METAR or our TAF when we're planning the flight, and Seattle is our destination airport, and our weather forecast says that we have 200 foot ceilings and a 1/2 mile visibility. We're still legal to dispatch that flight even though we're at those weather minimums. We're still legal. But at that point, because the 1, 2, 3 rule, what is the 1, 2, 3 rule?
1 hour before, 1 hour after estimated time of arrival, the ceiling above airport elevation will be 2,000, or you'll have a 2,000 ceiling above airport elevation, and you'll have 3 section miles of visibility.
Okay. So we don't have 2,000 foot ceilings or 3 miles of visibility at our ETA, right? So we're at landing minimums, so it requires us to list an alternate, right? And we choose Portland as our alternate. Okay. When we look at the Portland weather, we see that we have 400 foot ceilings and 1 mile visibility at Portland. At this point in time, we can list Portland as an alternate airport, as our first alternate airport, okay? But if we do list it as our first alternate airport, it will require us to put a second alternate airport in that is above the landing minimums. So we'd have to do, what? So I don't know. We'd list another airport, Medford, and it would have to be higher than weather minimums. So we'd have to have a forecast of at least, say, Medford is also, we can get I don't know what the actual landing minimums are, but let's say that Medford's landing minimums are 400 foot ceilings and 3/4 mile visibility. Our alternate minimums. Oops, man, I'm doing good. Would be if we could have, if we had 2 nav-aid on that, and it was the same, they were identical, we'd have to have 600 foot ceilings and 1 1/4 viz in order to list it as our second alternate. Does that make sense to everybody?
Yeah.
If it does, then you guys are way ahead of where I was, because that's all Chinese. That was all Chinese to me.
Okay, so
Garrett, I
I
got, go ahead.
I just have one quick question. So, we're not talking about landing minimums, right? We're talking about like when you clear the clouds, kind of like alternate minimums. Like that's the cloud ceiling, not decision height kind of thing.
What's a ceiling? What defines a ceiling?
The height above the Earth's surface at the lowest. No, sorry.
Nope. This is a definition. I really need you, because this is a definition that you have to have memorized word for word. So I
The
want
lowest
you
layer
right.
of broken, overcast, or vertical visibility.
It would be the
Right.
height above the Earth's surface of
Nope.
the lowest layer of.
Nope. Matt, I want you to hear what he just said.
I could have sworn we all wrote that down, but the lowest layer of broken or overcast clouds.
I guess I should word this like this. Okay. Write that down, memorize it. And where we're going to see that, let me minimize this really quick, is on our TAFs, okay? And we're going to get into the weather and how to read these METARs and TAFs in a little bit. But it is crucial that you guys understand the what we're talking about with our minimums here, and how these two apply, right? How these two link up. So when we're talking about ceilings, our landing minimums are our ceiling. It's reporting a ceiling height and a visibility height. Okay, ceiling is going to be our vertical visibility above the runway, and our visibility is going to be our horizontal visibility down the runway. Okay. So lowest layer of broken or overcast clouds or vertical visibility. We can see here in this weather report, let's just look at this line right here. Right now, or what this is reporting is that on the 2nd of February, from 0200 Zulu to 0600 Zulu, the winds will be coming from 150 degrees at 6 knots, 5 statute miles of visibility, light rain, and mist. Then we have a broken cloud layer at 700 feet and an overcast cloud layer at 2,200 feet. Okay. So just a real quick question, since we're talking about weather minimums. Would this forecast require an alternate? Just that blue highlighted line that we're looking at. Say our ETA is at 0200 Zulu.
I want to say no,
Okay.
Yeah, I'd say no.
but I can't read that. It's, I know we get to work on that as well.
Right.
Because we have 5 miles of visibility and the ceiling is 700.
Okay,
Well, you need at least a 2,000 ceiling, right?
right. So 1
Okay,
hour.
so yeah, it does.
I'm gonna write this down too. Even though you guys know it, I'm not saying you don't, but this is how we apply it. This is where the rubber meets the road. So okay. All right, so we'd look at this line, and at our ETA, we would look an hour before, right? So our hour before would fall into this line, and we're gonna, once again, we're gonna learn how to read these, and we're gonna learn how to apply this rule to it. But we'd look at this line before because this line starts at 0200 Zulu. So if our ETA was 0200 Zulu, this is exactly where we'd look. But to see and determine if we needed an alternate, we need to look an hour before, which would mean 0100 Zulu, right? So that would put us into this line. And then 0300 Zulu, which is before 0600 Zulu. But so anyways, it would fall onto this line. So these are the two lines that we would look at. Okay. So when we're trying to determine whether or not we need an alternate, we're going to look at these two lines and we're going to look at our visibility. We've got 5 miles of visibility, 5 miles of visibility. But we have a broken cloud layer and an overcast cloud layer. And then we have another broken cloud layer there and another overcast cloud layer there. Once we've seen that there's ceilings being reported, we're going to look at the height above the field that those ceilings are, right? This one's at 700 feet. This one's at 700 feet. So we don't have that 2,000 foot ceiling.
2,000.
Right. So yes, this would require an alternate airport. We have the visibility, we're just missing that ceiling. Okay. Would it say that we were using Seattle as our airport that we're going to land at, though? Looking at this to determine if we were even legal to dispatch it, all we have to do is look at our ETA. So if our ETA falls between 0200 Zulu and 0600 Zulu, this is the forecast we'd use. Okay, and so we'd look at this line, and I guess between 0200 Zulu and 0559 is what time this line is valid for. And we would just have to make sure that we have more than 200 foot ceilings, which, well, actually, sorry, when we're determining legal to go, we don't have to look at the ceiling. We just have to look at the visibility. Okay, so all we'd have to do is we'd have to look and see, look, we have to have a half mile of visibility. We have 5 miles of visibility. We're legal to dispatch this flight. But then after we determine that we're legal to dispatch, we're going to go and look at our ETA window and determine whether or not we need an alternate, which we already did. And we would go, yes, we're legal to dispatch. Yes, we need an alternate. And that's where we would start our planning. Okay. Does everybody got that?
Just as a side note, you've got 5 statute miles on your second line. What does the P stand for on the next one? P6 statute miles.
Great question. So this P, for some reason, some weather applications and stuff can't do a plus sign. So the P stands for greater than or plus. So this means that you have more than 6 miles of visibility right here. Does that make sense?
And 6 is the maximum, right? It'll never show anything above that.
Yeah, in a TAF, you won't see you wouldn't see anything higher than a 6. In a METAR, you'll see 10, or you'll see a skies clear, but you won't. And even in a, or yeah, so for visibility in a METAR, you'll see higher than 6. You'll see probably a 10 or a 10 plus, but after that, it's pretty much pointless to have the visibility go any higher than that. So, any other questions? I mean, we're going to get to this, so don't feel like you have to learn this right now or how to apply these rules. We're going to get to all of that. I just wanted to show you guys kind of what we're talking about when we're talking about minimums and alternate minimums.
So on your document, take me through that again on the Portland. Kind of see where you're going on the Medford, but
Yeah.
the 200.5 and then 401. I get the 401, but is that because the 201 and one nav aid, and the second, of course, you have 2.
Yeah.
So you added the 200.5 to the 1 or the 403/4.
Yeah, so let me put this on here too really quick. So, oops. Man, I'm just on fire today with typing. My brain's pretty much fried from work this week. Let's
Did
see.
you learn the 233 airports?
We're on the last 40 tomorrow, so
Awesome.
actually I think we only have like 30 on this round, so for one nav aid, what we have to add to the ceiling and visibility would be 400 feet and 1 statute mile to the viz. So
And 200.5.
right. Okay. So that's just kind of what we did here with Portland, Oregon. So Seattle is our, let's say Seattle was reporting. We're not going to use this because this is not the right forecast that would justify what we're doing here, what I'm trying to accomplish in teaching you guys. So remember that here we are talking about marginal weather. Okay. So we're talking about marginal weather here. So the way SkyWest defines marginal weather is when at the destination and our first alternate the weather is at landing minimums. Okay. That's how we define marginal weather. I'll even write that on here. Yeah. That sounds good. Okay. So what we're doing in our demonstration here is say that TAF, we look at our TAF and we see a broken cloud layer at 200 feet and we're reporting a half mile of visibility. And let's say that's Seattle's landing minimums. So that would make this at landing minimums. Okay. And we check that one off our list. So we see that and we go, perfect. At our ETA, we have we're legal to dispatch. We see that the forecast is saying that we have a half-mile visibility, and that's basically what we have to have, is that half-mile visibility. We're legal to dispatch this flight.
We're assuming 2 nav aids.
So this doesn't come into play. This is all. This is when we're talking about. I'm gonna only applies to alternates. Okay. So I'm going to try to dump as much info onto this sheet for you guys to look at. Okay. Okay. So you guys can screenshot that if you want. That is what we need to know. Okay. So going back to this, we see that at Seattle, we're at landing minimums in our forecast. So we go and look at Portland because we decide, this is below that 1, 2, 3 rule, right? We apply the 1, 2, 3 rule, and we look at the weather. In our ETA window, we have less than 2,000 foot ceilings or less than visibility. Okay. So that means that we have to have it. We have to list an alternate airport. So this would be our first alternate. Okay. Once we go to Portland, we look at the weather, and our weather is reporting that we have 400 foot ceilings and 1 mile visibility at our ETA for Portland. Okay. We look at Portland's approach charts and see that our landing minimums are 200 foot and half mile, and we apply the 2 nav aid rule. So we find out that Portland's alternate landing minimums are 400 feet and 1 mile visibility. Okay, because when we apply this rule, we go 200, 200. That equals our 400, and then we go half mile, that equals 1 mile visibility. So at that point, we see that Portland is at alternate landing minimums. Here, I'm going to expand this out. Okay. So once we see that Portland, it's still legal for us to use as an alternate because we have our landing minimums, right? So we can list it as our first alternate. But what marginal weather is telling us is that if we have our landing minimums at the destination here and at our alternate, like the weather's reporting that it's at those minimums, it requires us to list a second alternate. Okay. We don't even need to really see this part here. Well, just to simplify things, we'll just kind of, okay, simplify it a little bit. So if at the destination and at our alternate airport we have, or the weather is at the landing minimums, then we have to list a second alternate. Does anybody have questions on that? Did I completely fry your guys' brains with that? That's a whole lot of information.
I'm right on the edge of even having a clue. So
We're going to get really in depth with this. This is like your number one thing that you're going to do as a dispatcher, is determining if we're legal to go and determining what alternates, or if we need an alternate, and what alternates we have, what the alternates have to be. This is like 95% of your job. Probably not quite that much, but you get the point. It's an extremely important part of your job. So since I've completely thrown a whole ton of stuff at you, I'm going to give you guys a 30-minute break for dinner if everybody's good with that.
Sounds good to me.
Sounds good. Thanks.
Yep.
Skywest should really invest in some CRJ 1000s.
Oh, we got something better. We're ahead of the times now. We got the Embraer 175s. So.
And we're getting more.
Yep, we're getting a lot more. CRJs are kind of outdated. Well, they're not outdated. They're getting there, though. We keep updating them, but the E175s are a little more efficient and cooler. Cockpits are awesome in the E175s. Anyways, so let's talk about the standard alternate minimums. Okay, so this is talking about just our standard alternate minimums. Once again, this is super subjective. Our alternate minimums will vary by airport. They'll vary by what company you're working for. SkyWest, right? Depends on if we have one navigational aid or two navigational aid approaches. Just there's a lot of factors that come into play. And so we'll go a little bit more into these alternate minimums. Published in the TPP again, for higher than standard. So our op specs allow us lower than alternate, or lower than standard minimums. And it depends on, like I said before, one nav aid or two nav aids. It depends on, are we doing a circling approach or a straight in approach? So for one nav aid, we kind of hit this already, right? 400 feet to the ceiling, 1 mile to the visibility. So if there's only one navigational aid or one instrument approach that's usable, we're going to add 400 feet to the ceiling and 1 mile to the visibility.
Hey, Garrett, can I ask on that last slide for the ceiling, what's HAA or HAT? What's that acronym for?
I honestly don't know. These slides were created about 10 years ago. I believe that means height above airport or height above terrain. But what the forecast needs to say is that 400-foot ceiling, so 400 feet above the runway, right? So the forecast just is what we need it to read is that 400-foot ceilings, and 400 feet on top of our our already required minimum, and then we'll add another 1 mile to the visibility. So height above approach maybe.
So I looked it up real quick. It's height above airport and height above touchdown.
Okay.
I was just curious.
Yeah. So yeah, I didn't create these slides, so we just use them. They were actually created for Salt Lake Community College originally, way back in the day, back when before Adam started teaching there. We've kind of adopted them and used them, but yeah, there's a lot of good information in them still. So departure considerations. The first thing, like we were talking about on that example that we broke down and dove into, was we need to ask the following questions. Am I legal to dispatch? So visibility at the destination. So remember, when we're talking legal to go, we're only looking at the visibility at the destination for our instrument approach, okay? We're not looking at our ceilings at that point. Okay, when we if we have a high minimums captain, so he's within that first 100 hours in the type and part, we're going to increase that that ceiling by 100 feet and add a half mile to the visibility. So when we're flying a high minimums captain, we have to have both visibility and ceiling. So can I shoot the instrument approach to the suitable runway at the ETA at the destination? That's what we went over with this information here. Even though this is at landing minimums, like even if the weather was reporting half mile visibility, we'd still be legal to dispatch. Okay. Once we've determined whether or not we're legal to dispatch, we look at, are we legal to even take off? So we need to refer to our departure airport and look and see if they have minimums for departure and whether or not they're below that. So say that the minimums were 500, 500, 500, and we've got a mile of visibility at our departure airport. We're legal to depart depart that airport. So so do I need a departure alternate? So if we were anything below those minimums, it would require us to add a departure alternate. And then we'll apply the 1, 2, 3 rule to our forecast for the destination airport and determine whether or not we need an alternate. And then as we discussed in that example, do I need a second alternate based on the marginal weather at the destination and first alternate? So departure procedures. So there's 2 types of departure procedures. The only type that we're going to look at are the SIDS, Standard Instrument Departure Procedures. ODPs, obstacle, just stands for Obstacle Departure Procedures. So if there's terrain or something else that requires a special departure procedure, that's when we would see those. But like I said before, we're only going to be using SIDS and STARS in this class. So they're published both textual and graphic format, and they provide obstacle clearance protection in instrument meteorological conditions, reduce communication and departure delays, and allow a departure and transition to en route structure. So what this means is it allows us to depart and get onto our en route, our cruise segment of our flight plan, without having to talk or or be too busy in the cockpit. The departure standards, so TIRPS, it's the U.S. standards for terminal instrument procedures. So aircraft climbing at least 200 feet per nautical mile or greater than 35 feet at departure end of the runway. Aircraft have to be able to climb 400 feet above airport elevation within 200 nautical miles. And this provides us obstacle clearance slope. So if we have an obstacle to clear, my gosh, if we have an obstacle to clear and have to fly that obstacle departure procedure, that requires us to be able to climb at 152 feet per nautical mile. So these are just those departure procedures depending on, what our aircraft is able to do is where we fall, and we'll determine, if we can even do the departure. So if we don't meet the standards, don't meet standards. Yeah, basic, graphic or textural, and just the ODPs provide us obstacle clearance once again. So the way we'd see an ODP is it would be notated by this T that you see, T in a triangle. So let's see what airport this is for. So this would be for Afton, Wyoming, Albany, Oregon, Anaconda, Montana, and Arco, Idaho. All right, so let's just kind of jump through these ODPs. I promise you won't ever be tested on an ODP. So SID, standard instrument departure procedures. They're graphical, 2 types, right? Pilot nav and vectored departures. The purpose is to transition between airport and en route, our en route structure. Once again, it's just basically this time we're not trying to clear an obstacle with this one necessarily. So they simplify our complex departure procedures. It reduces our radio congestion. It controls our the airplane traffic, the traffic in and out of the airport. It allows for noise abatement procedures in California, like Long Beach and some of these, like Orange County and stuff like that. Some of them have noise abatement procedures where we have to fly special routes so that, people's ears don't have to be constantly bombarded by aircraft flying overhead. There's some obstacle clearance requirements, and they give us a little more detail. So less room for error, improved traffic flow. So all the stuff that we've already discussed, right? So responsibilities of the pilot in command. So his responsibility is to accept the departure procedures and comply with performance. He also has to comply with the climb gradient, so we'll look at that. And then he has to be able to follow the textual description of the charted procedure. Okay? Basically, don't accept any clearance you can't comply with as a pilot in command. And then If the pilot doesn't want that departure procedure, he can remark. He can put that in the remarks section. So this is what your SID looks like. This would be Salt Lake City 2 departure, Salt Lake 2. And this, it was talking about the textural, got to be able to comply with the textural and the climb out of these charts. We're not going to get too much into it, but this is just giving us our takeoff minimums, depending on which runway you're on. You're assigned a heading of 160 with a minimum climb of 260 feet per nautical mile to 6,000 feet. Assigned heading 280, and then you're going to turn to 340, standard with minimum climb of 400 feet per nautical mile to 8,300. So continue west to 340, right? And then runway 32, you're going to do that. Runway 34 left, right, 35, you're going to do that. So the pilot has to be able to follow those procedures as he's leaving, as he's taking off from the runways. So this would be basically what he would fly to get out of the airport. These, do you guys remember what these are from yesterday?
Yeah, those are VOR identifiers.
Yeah, so this tells us the VORs in the area that we're going to use for our navigation. We got Twin Falls up here, Malad City, Rock Springs, Wasatch VOR, Fairfield, Mighton, Grand Junction, and Delta. Okay, this is telling you that there's restricted airspace out to the west. And it kind of gives you a pattern of what those restricted airspaces, whereabouts they would be. This is not in any way, shape, or form a scale representation of the area. So, so yeah, this will also show you, this is the compass heading, right? So this is how you'd rotate the map to point north. This kind of gives you some direction indicators there. Here's all your frequencies. So for automated terminal information service, these are the radio frequencies that you would tune into to get your weather and any terminal information that's pertinent to the flight. To contact clearance or clearance delivery, you'd contact these radio frequencies, and then Salt Lake City departure, contact them on these frequencies. This tells you which airport it's for, Salt Lake City. Does everybody see that? This will also tell you the departure. So this is the SID. This is the title of the SID, right? Salt Lake City or Salt Lake 2 departure. And this is how we would notate it on our IFR flight plan, SLC2. And our exit point would be TCH. Does anybody have any questions on that?
No, sir.
Okay. So this is what a Jeppesen SID looks like. Okay. Can anybody tell me what airport this would be for?
Ontario International Airport.
Okay. Ontario where? Which Ontario?
California.
There you go. So Ontario, California. It also tells you up in this corner that it is a SID, Standard Instrument Departure. Okay. There's a couple minor differences on this chart. It's a little bit cleaner than this chart, isn't it? Oops. I don't know. The JEP charts seem to be a little bit cleaner. But it gives you the same information on the JEP chart, just in a little bit different location. So this is giving us our frequencies, right? If we're departing north, northeast, this is a frequency, northeast, east. That's the frequency, east to south, south to southwest, southwest to north. So that gives us our frequencies to contact departure. This is also going to give us, once again, our information on how we need to fly this once we've taken off. It gives us our requirements for ground speeds and for climb out. It tells us what transitions we're going to use. So a transition is where we go from basically from takeoff and to these points. These are our transitions, okay? So Daggett, this is the transition we'd follow. Palmdale, if we were exiting the route on Palmdale, this is the transition that we'd follow right here. And then we also have direct distance from Ontario International to POM, Pomona, VOR, is 9 nautical miles, okay? This gives us a visual of our runways, and if we were to depart heading eastbound, we would make our turn, and it actually tells us the procedure here, but we would just make a right-hand turn, get on heading 255, and then once we got to this point that it identifies up here, we would make our turn to 323 and follow that to our transitions. Okay. So just like it when we're looking at our high altitude and route charts or low altitude and route charts, we also have information underneath our routes here that what do you think they mean?
Need to be at least 12,000 feet.
Okay. Yep. And then what is the lower number?
How many miles from one to the other?
Okay. Good job. Those are our altitude requirements. And then how many miles between this point and this point, or this point and this point, or this point and this point, so on. At these intersections, this is giving us what VOR we're using as a reference. So what this is saying is that we're flying on the 323 radial of the Pomona VOR, and at 8 miles from that VOR, if we're staying on that 323 radial, 8 miles from that point, we'd know that we were at that intersection because we would tune into the Los Angeles VOR, and we would be off the Los Angeles VOR's 046 degree radial. So it just gives us basically a crosshair of our location, right? Is this making sense to everybody?
Yes, sir.
All right.
It will make more sense later.
Yeah, it will. And I encourage you guys to, once again, as we keep going through this stuff, come back and watch these classes. I promise you, I'm not getting too far out anymore with not recording, so it should pretty much have everything that we talked about. We're getting better. You guys are keeping me on track too. So, anyways, the other thing to note on here is, once again, we have a compass, and it tells us which way to point the map to see north, okay? Come on. Okay, so this is what we call a vector SID, okay? Vector SID, we aren't going to use in this chart, but basically this gives us all the VORs. If we were to contact air traffic control and say that we wanted to vector to Vancouver, basically we would fly directly from the airport to Vancouver. This just tells us the different VORs in the area. Okay, expect vector assigned route. So this is basically saying ATC is going to assign you the route to that VOR. Mandatory 2,000 feet at least. So you're going to come off the runway and just start heading 130. So this, once again, gives your climb out requirement. This gives you your departure requirements as well. Fly a heading of 130. Expect vector assigned route, maintain 2,000 feet, and expect clearance to filed altitude within 6 nautical miles of the airport. This is for Seattle, Washington, Boeing Field. And here's your frequencies once again. And we know it's a SID because it's labeled SID. And then here's your compass to help you see north. So the standard terminal arrivals don't get much different. They are set up virtually the same. When we're looking at a star chart, once again, it gives us our identifier as to what airport we're flying into. It gives us the name of our arrival, okay, Brigham City 3 arrival. This is how we notate it on our flight plan. So on a SID, let's go back to the SID really quick. So when we're writing an IFR flight plan with a SID, this first set of letters and numbers, the PCOP2, I don't know how you say that word. I hope I said it right. PCOP2. That's saying the PCOP2 departure. Okay. And then this is our transition point for this departure. So this is saying that we're going to transition at PCOP, right? So let's find the PCOP VOR. Let's see. Oh, this is RNAV. So it's talking about a transition. So this would be our transition point is PCOP. Okay. But let's go. Okay. So this would be our transition. Just if it were a standard departure procedure, not an RNAV. And we see that it's RNAV, which means it's GPS, right? We see RNAV indication right here. So it's using a GPS waypoint as its transition point. But when we go to this chart, right? Well, actually, that Jeppesen chart, actually. So this is what I'm trying to say. This is your standard instrument departure, okay? So this is, let's see. Okay, so this is the HASA 4 departure. This is how we'd notate it on our IFR flight plan, HASA 4, and then that dot, and then this is our transition point, Okay, this is where we're going to exit that route. Okay, so that means that we're going to fly to Palmdale VOR, POM. This is our transition point. Okay. It's the same thing with the star chart. LHO, it's just in reverse. So LHO is our transition point. Find LHO, Brigham City right here. This is our transition point. So we can come into this transition point from any one of these VORs. Does that make sense? But this is our official transition point. And then this is our arrival, LHO3. Okay. Once again, it labels our VORs, our ground base identifiers, with these info boxes. It tells us what frequency to tune into on our navigational radios to pick up those. Oops. Let's go into this. Okay, this is the same one. This is our localizer. Okay. If you guys remember that, landing south after Carter, initial, fly heading 170 to intercept the IMOI localizer, and then proceed inbound and expect ILS DME runway 16 left approach. Okay, so if this is if we were landing to the south, this is the point where we depart and go into our approach. And if we were landing to the north, let's see if that other chart shows it. Doesn't. Anyways, so yeah, that's our arrival. Here's our transition point once again, and these are the other transition points. These are the VORs, the routes that we can use to navigate us into this transition point of Brigham City. Okay. The star, what are they? Transition from an en route structure to a terminal area. So it's just the reverse of a SID, like we said before. Begins at a common nav, aid, or intersection. Here's our intersection. Okay. And then it terminates with a visual approach or instrument approach procedure. So once we're ready to start our approach into the actual runway, that's when we stop using this chart. So the purpose, once again, transition between en route to our airport setting. It's going to sequence aircraft into their instrument approach procedures, instrument approaches. It reduces the radio congestions for ATC, and then it simplifies the complex clearances, simplifies the complex clearances and reduces frequency congestion for air traffic control. And then I'm not sure what that CD is, and improve traffic flow. So then it also is for noise abatement procedures. So to use it, you have that text description, the notes, limitation, and performances. And how does a pilot get one? It's on file with the FAA. When you file an FAA flight plan, air traffic control clearance, and then don't want it, notate it in the remarks. So we talked about this, right? So once again, this is your star name, right? Star name, and this is your star number. And this is the transition point. Does everybody understand what I mean when I say transition point? You guys know why it's called a transition point?
Wouldn't it be because so? Hold on, let me think of my words.
It's where you're
That's where they
switching from one
transition
frequency to the other.
Transition from what?
Like one flight plan or one vector, I guess.
Yeah, so yeah, you're pretty close. So it's the transition. Once again, as it stated in this last slide, or not this last slide, but the one before it,
Correct.
it is the transition between en route to our airport. That's why we call it transition. So the transition is that point where we go from an en route setting to an approach setting, or we're descending into our airport. Now, our descent isn't necessarily going to start at that transition point. It's just where we're coming out of that en route setting and we're getting ready for landing. Okay. Once again, this is our transition information. Tells us where the star begins. You got your graphical and your textual info. So it gives us our altitudes here for flying this arrival. Oops, goodness sakes. So this is the altitude that we're supposed to be at when we're flying that segment, right, at this transition. This is a changeover point. These crooked lines like this, we call this is a changeover point. This is the point where we turn from this VOR and tune into this VOR right here. Okay, so this is that changeover point. This little circle here, we call that, that's a holding point, right? So if we're coming in for landing and air traffic control tells us to hold over the Brigham City VOR, this is where we would do that hold procedure. This is our route segment distance. So from this point right here, this intersection, to this VOR is 55 miles. Okay. This tells us like if we were to look at the route number, we could actually see on some charts a little more description about that.
How come that, Garrett, how come that 55 miles is in parentheses? The miles aren't always in parentheses.
So these miles are going to be in parentheses on a star chart. That's just telling you overall distance from here to here. So on a star chart, it's going to change just a little bit, right? Does that answer your question?
Yes.
In areas, sorry, I wanted to ask this yesterday, but how many aircrafts can be in that holding area? Is it just one, or can multiple aircrafts be in that area?
So a lot of aircraft actually can be in this area. And that's why we have, there's not really a set or defined number. So we'll go into this when we talk about air traffic control. But they have a certain number, we call it a flow program, where they can only accept a certain number of aircraft into the airport over a given period of time, right? And so that's why we have these holding patterns. If it gets too congested, or say we have a really fast moving plane that's closing in on a slower moving plane that takes a little longer to get to the airport, they can put them into these holding patterns, and it just slows them down so that, you know, the traffic can separate. Remember, their primary job is to separate and sequence the aircraft into the airport, right? So we could have 200 airplanes in this given area here. And remember too, these are miles here. So even though this is on one chart, these VORs are separated by sometimes hundreds of miles. Like this VOR is 135 miles out, Rock Springs. Not very close to Brigham City VOR or Brigham City, but we're using it as a reference point to get into our transition here. So we could have hundreds of aircraft in this area, but air traffic control, what they're doing is this is allowing them to funnel them into the airport and set them up on those nice approaches where you see those airplanes coming in like clockwork, So yeah, it just depends on the area, and how, time of day, number of aircraft that they're trying to get into the airport. So so yeah, some of the other things to note here, when you see this degree here, the straight line from VOR to VOR, that's going to be the radial that you fly. We call those radials, right? Kind of talked about this yesterday. So that's the course that the pilot's going to fly to get from this point to this point. Once again, this is the miles and this is the flight level they're supposed to be at when they're flying this segment. So we'll keep moving on here. And this just goes over the things that we talked about. This is those procedures once we hit this transition point. So this is the Brigham City VOR once again. Once we hit that transition point, it's going to start telling us, this is how you're actually going to set up for that approach into the airport. If you're landing from the north to the south, this is the procedure for that. And if you're landing from the south heading north, this is the procedure to get there. So it's not going to give us the specifics of the actual approach. It's just going to get us to those approach points, and then we'll use the approach plate to go into the actual airport. Sorry, let me get a drink really quick. So as you see here, there's also more to this chart. They couldn't fit all of the narrative, all of the textual information onto this one page here. And so when there's extra pages, you'll see this notation on the bottom, narrative on the following page. And that's going to give you more information. This is the extra information that it's talking about. This is that information. So once again, it's just giving you the textual information about how to set up on the approaches. Anybody else have any questions about this chart that you'd like me to go over? Or?
No, I'm good.
All right. Once again, the Jeppesen chart is going to be very similar. All the information, so the FAA requires the same information from both charts. It's just Jeppesen formats it a little bit differently. Does that make sense? That's the only difference between the two charts. Like I said, Jeppesen tends to be a little bit more clean of a chart, a lot easier to visualize. But there's where they put their textual information. But you'll see the same information as you saw on the NACO chart. You still see the VORs here. You see the headings. This is the transition point, right? You go from these dotted lines into a solid line. This would be your transition point. These VORs are for reference only for information on these intersections to help the pilots know when they're hitting these intersections. This is when you start the approach procedure. On a Jeppesen chart, you'll see this kind of like Christmas tree type thing. This is where the instrument approach procedure actually starts for the airport. This gives you a little bit more information. So turbojets, Miami International Landing East, expect clearance to cross at 250 knots and 10,000 feet. And then if you're landing west, expect clearance to cross at 250 knots and 1,600 feet. So once again, same information, just a little different format.
So Garrett, on that Christmas tree, that's considered the approach. So I had a question just on the ADX where it's talking about if it drops below minimums, when can you still land? And the answer was once you begin your approach. So is that once you hit that mark?
Yeah. So on an instrument approach plate, which we'll go over, this is that transition from the SID. I'm sorry. This is the transition point from the star to that instrument approach plate. So at this point, this is when the pilot's going to switch over to his instrument approach plate. And at that point, when he's started that approach, as soon as he crosses that, say weather all of a sudden tanks, the pilot has the ability and the right to continue on with the approach to the decision height at that point. So he's already started the approach. It's like, sorry, too late, He can continue his approach into the airport at that point. So yeah, that is that point that it's specifically talking about. Great question. Did everybody hear that question? Does everybody recognize it that's studying for the ADX?
Do it again.
So there's a question on the ADX that says when can Greg, I can't remember the words good enough to repeat the question.
It says something to the effect that if the weather minimums fall below, or if the weather falls below landing minimums, what may a pilot do? And then it gives you three choices, one of which is continue if on final approach, something like that. So.
Yeah, continue if he's initiated his approach.
Yeah, so like if a pilot has already begun his approach before the landing minimums kick in, then I believe he's allowed to continue that approach. But if he hasn't begun the approach before the landing of the RVR, like below RVR kicks in or whatever, then he has to divert. Am I saying that correctly?
Yeah, the gist and all that we're saying, the reason why he brought that up was this is the point. If you look at the screen here, this is the point at which he starts that approach. Does that make sense? So this is the changeover point from chart to chart. This is when the pilot would flip his chart over, or if he's using his computer system, his GPS, this is a point where it would switch over from an arrival chart to an approach chart. So that's all he was saying. So yeah, once a pilot passes that point, he can continue on even if the weather is below minimums. If the weather at that point changes to below minimums, I can't say. Got to be careful there. Anyways, that covers our SID and star charts. Why don't we take a 10-minute break and we'll jump back on. All right, is everybody back?
Yes.
Yes.
Okay. Does anybody have any questions on that material or?
No.
All right. Okay, so we've covered the star and SID routes, and you know, our minimums. Now we're going to look at the instrument approach plates. So here we go. So the outline, instrument approach charts. We're going to go over the NACO and the Jeppesen, inoperative equipment, airport charts, ILS approaches, and RNAV approaches. We're not really going to touch on this RNAV approach because, I mean, everybody knows what RNAV is, right? We've gone over this.
Yeah.
So RNAV just doesn't really apply to what we're doing in this class, with it being GPS. So that being said, we'll touch on it, but I don't want to add it in and make things even more confusing for you guys, if we can avoid it. So, sorry, just double checking, making sure I'm recording. So let's jump into this. Purpose of instrument approach procedures is to provide a method to descend and land safely in low visibility condition. TERPS establishes criteria and standardization. Criteria and standardization methods. So the types of instrument approach procedures. This you guys really need to make note of. Write it down. Precision approaches. So there's two types of approaches. There's a precision approach and a non-precision approach. This will be tested on, or this will be on your test. When we're talking about precision approaches, what makes them different is that they provide us both vertical and horizontal navigation into the runway. And we've talked about this. We talked about this a little bit last week. We're going to get a little more in depth with it now. So the type of approaches that we're going to see that are precision approaches are going to be your ILS or your RNAV approach. Other types would be a PAR approach. We won't use those either. So pretty much the only precision approach that you guys are going to use in your flight planning will be an ILS approach. Okay. Now, a non-precision approach only provides us horizontal navigation. So to the left or to the right of the runway. So the types of navigation that you guys will be using for these non-precision approaches, will be like your localizer approaches, VOR approaches, GPS, and NDB approaches. The other type would be SAR. Once again, we won't be using SAR, we won't be using an NDB or a GPS. The only types of instrument approach procedures we're going to use in this class are either going to be ILS, localizer, or VOR. So the really important key things that you guys need to take away from this is precision and non-precision approaches. The difference is precision provides us vertical and horizontal navigation. Non-precision approaches only provide us horizontal navigation. I think there's a test question also that says, what would be considered a precision approach, and it'll list out a handful of approach types. So ILS or RNAV are going to be your answer to that. And then it'll say, what is a non-precision approach? And VOR, localizer, GPS, NDB, those would be the answers to that. Anybody have questions on that?
Can you go back for just a minute? I'm almost done taking that.
Sorry, you guys, my throat's really dry. Give me 30 seconds. I'll be right back. All right. Everybody done with this screen?
Yep.
Okay.
Yep.
All right, approach segments. So there's 4 approach segments. We got initial. So this begins the instrument approach, right, at the initial approach fix. So we navigated to this initial approach fix with our star chart, right? So this is that transition point from the star into our instrument approach. So IAF, initial approach fix. Intermediate portion begins at the initial fix or position within 30 degrees of the final approach fix. Okay. Sorry, intermediate approach fix, not at the initial approach, at the intermediate approach fix. Okay. And it ends at the final approach fix. Then the final begins at the final approach fix to the missed approach fix, or missed approach point. Okay. And then the missed approach begins at the missed approach point to the holding point. Does everybody see that path? Does it make sense? So a missed approach is if we got down to the decision height, couldn't see the runway, that's when we would go onto this missed approach segment. Okay, so the final approach fix is either going to end at the runway or at that missed approach fix, missed approach point. Does that make sense?
Yep.
Okay.
I think it does.
So the 2D representation of that is what we're going to see on our instrument approach procedure. So this is going to give us, this is the profile from that initial approach fix to our intermediate to our final approach fix, and then to our missed approach fix. You guys see that? 1, 2, 3, 4. Okay. So it breaks out the 4 segments so that you guys can see the profile of the aircraft coming into the airport. This part up here gives us briefing and procedure notes. This tells us what instrument we're going to be using for our approach. So it's a localizer. This is the 3-letter identifier for the station for the VOR, and this is the frequency that we will use to navigate to that VOR for this approach. Our true approach course will be 070 for this approach. This is giving us our runway lengths. So runway landing, 5,703 feet. Our touchdown zone, TDZE stands for touchdown zone, is 109 feet. And then our airport elevation is 113 feet MSL. So what it says here is, you guys remember what that symbol means?
What does it say, TA?
Well, just the top one. You guys remember seeing that sign on the last slideshow? It stands for obstacle, okay? And this has given us some other information. So in minimum visibility conditions, bright lights on highway half-mile south of the airport may be mistaken for runway lights. And then it gives us a requirement, radar or DME required for this approach. This tells us the lighting system we have. Mauser, I want you guys to write this one down. We're going to go into a little more depth in one of our later lessons about the different lighting systems when we talk about airports, but Mauser stands for medium intensity. Oh man. Medium intensity runway lighting system. Let me double check that really quick. For some reason that felt wrong when I said it. Okay. Medium intensity approach lighting system. I was close. So write that down. MALSR. Medium intensity approach lighting system. So everybody got it? That will be on a test. Maybe not this one coming up, but definitely on one of the ones in the class. So I'm giving you guys a head start on that one. Just to go over some of the stuff that we messed up here. Issuing authority, the procedure ID. So this tells us it's an ILS approach or localizer approach to runway 7 at Orlando Executive. And this is our airport code, ORL. Okay. This gives the pilots, once again, it gives the pilots notes. Descent to 1,200 feet may be required when executing an early missed approach. And then this part right here is really important to remember. This is where we find our missed approach procedure. This will be asked by the inspector on your practical test. He'll show you this chart and he'll say, where's the missed approach procedure? And this is what you'll show him right here. Missed approach, climb to 1,200 feet maximum altitude via ORL East course to SOTCO/Orlando, 1.5 DME, so 1.5 from the DME. Radar, then climbing left turn to 1,500 feet via this radial, the 049 radial to Oviedo intersection, Orlando, 13 DME required and hold. So all of that means fly this course right here and then hold right there, waiting for instruction from air traffic control. This kind of gives you an overview of the profile once again. So here's your initial approach fix. This is a 10 nautical mile circle around the airport, right? Here's your initial approach fix. Intermediate, final missed approach fix. Okay. So that MM also stands for middle marker, and that's right there. This is your outer marker, middle marker. This X on the map, or on this profile here, that's where you start that final descent into the runway. Okay, once again, more information. Just right here, providing you more information about the profile here. These little triangles up here, these are obstacles with the heights of the obstacles. So these are in MSL. So 1,749 feet, 16,700 or 1,675 feet. This tells you the highest obstacle in a 25 nautical mile radius. It's 3,000 feet. And then this gives you, this is kind of like a, you guys remember that AFD that I kind of showed you? This is like that overhead snapshot of where the terminals and taxiways are for the airport. Gives you also runway dimensions, runway headings, obstacles, all that information. Tells you the length of the touchdown zone. And yeah, this tells you more information about like runway lighting systems and speeds here. And then here's the part we've all been waiting for. This is where our minimums will be. Okay, so we talked about our legal to go and alternate minimums and things of that nature. When we're looking at an instrument approach procedure, this is going to be the section where we always find our minimums. Okay. So let's move on here. So this goes into a little more depth of what we saw. We'll have our city, state, and airport, and the procedure title, navigation requirements, and amendments. So this tells you your amendment number. This is Amendment 4C. It was released the 25th of August, 2011. This tells you the location of the airport in longitude and latitude. Yeah, once again, presiding authority, FAA, right? And then just all the information that we've already gone over. So, instrument procedural titles and types, straight in and circling only procedures. So straight in procedures tells us the runway listed, and then greater than or equal to 2 instrument approaches the same guidance system to the same runway. Example, when there's 2 approaches into the same runway, it will notate that they're different approaches with the Z and Y, or with some sort of lettering. So for the GPS approach, even though they're both RNAV approaches, your GPS approach will be the Z, and your RNAV will be an RMP approach, notated with a Y. Circling only procedures do not have straight-in landing minimums. So circling procedures are going to be non-precision approaches that have really high minimums, and we try to avoid using the circle approaches. Okay, circling approaches. The final approach, alignment from the runway is greater than 30 degrees. So the final approach course alignment from the runway is greater than 30 degrees. So that's when we would use a circling minimum, is if we couldn't do a straight in, like there's an obstacle or something in the way of the runway where we would have to, in order to avoid it, we would have to basically do a circle or a half circle into the approach. And the descent gradient is greater than 400 feet per nautical mile from final approach fix to the touchdown. Okay, pilot briefing, TA, navigate and frequency, or navigate and frequency. So this is just, once again, this is the notating some of the requirements and some of the notes about the procedure. The NavAid, this is your NavAid box, and frequency. This is the frequency of ATIS, so that automated weather and information service. This is your approach frequencies, Ogden Tower frequencies, ground. So once we've pulled off the runway, we'd contact ground. This is our frequency. Unicom. Unicom just means that it's a frequency that everybody can monitor and talk to each other. Approach course into the runway, once again, is going to be notated here. This gives us our runway length, touchdown zone, and the airport elevation. This is our lighting system, and then here's our missed approach procedure. Does anybody have any questions so far?
Sorry, what was the CRS, the app CRS? Up top there,
this
top
one?
left.
So
Yeah.
this is the true course. So this is the actual heading that the pilot will fly for the runway. So the approach course he'll actually be flying 031. He may be
approach course.
Yeah, so he may be flying and landing on runway 3. See, this is runway 3. So this is the approach for runway 3. This is the actual course he would fly, is 031. So they always, with the runways, they always round to the nearest 10th. So, or 10. I don't. So. Any other questions about this top section? Okay. That middle portion of the map, once again, this is the plan view. So it's the overhead view of the instrument approach procedure. Has your initial fix and your intermediate fix notated on there. Initial fix. initial fix and intermediate fix. This will be your final approach fix, and your missed approach fix would be about right there. Cross radials to identify the fixes. So that's these cross points right here to help you identify those points. The flyable radials are in bold. So you're not going to fly the 296 radial off the Wasatch VOR there. You're going to fly this bold segment here into that runway. This MSA, once again, this is just telling you in a 360 degree circle, 25 nautical mile circle around the airport. These are your highest obstacles in those areas. So from 160 to 325, you have an obstacle. So we're talking over in this corner, right? We have an obstacle. The highest obstacle would be 11,000 feet. And the highest obstacle on this side of the airport is going to be 8,600 feet. Okay. And then it shows you just kind of a visual of the missed approach track. So this is what happens on the missed approach. This last slide tells you the actual in detail approach, missed approach procedure. This just kind of gives you a visual. It's not, once again, it's not to scale or anything, but it just gives you that visual of what it will look like. These darker spots and then the black dots on top, that's the highest point. So it's showing you that this peak is at 8,136 feet, 9,570 feet, 9,706 feet, and so on. Same out here. Tells you the highest points. And then these chevrons with the dot, that's showing you the obstacles that are in the vicinity of the airport. This dark circle, once again, as we see right here, 10 nautical mile circle around the airport. So it's going to give you a little more detail in that circle. Any questions about that? And this is, oops, oh man, stinking mouse. This gives you that gradient up to that altitude as well. Kind of shows you the contour of those peaks. Okay, profile view. Once again, it's just that profile or side view of the approach. We still have everybody on here? Okay. The missed approach is abbreviated right here. Okay, it's telling you fly straight to an altitude of 4,900 feet, then a left turn to 6,000 feet over the Ogden VOR. This is just giving you a visual representation of that missed approach procedure. Okay. This shows you that initial approach fix, intermediate, final approach, and missed approach. Okay. Once again, this is that final descent. This is where the pilot starts that. Do you guys remember the gradient or the angle that these approaches are at?
3%.
3%. Okay. So this is just where he starts that 3% gradient into the runway. If it's anything more or less more than that, then it will notate that degree, that angle. This shows you the distances from these fixes. So from there to there, 9.4 miles, 3.5 miles, 1.1, and then runway. Okay. Any questions on this?
Garrett, is this where the 1.1 is or the 2.5 cursor? Is that the decision height right there?
This one right here?
Right, that little arrow right there, that V looking thing. Is that where the decision height is? Because then it looks like you go up for the missed approach.
Yeah, so that's where he would declare missed, yeah.
Okay.
Yeah, that's where he would start that missed approach procedure.
Okay.
So yeah, decision height. Good question. Anybody else? You can see here too how we said that gradient coming into the runway was 3%. Here it notates that glide slope, GS, glide slope 3%. This just tells you the VOR TCH 49.
So what does that TCH 49 mean? Like, what is that?
So that's the station identifier using Wasatch VOR. I believe. Oh, wait. I may be wrong on that. 1 second. Sorry, we're using Salt Lake stuff, so it's mixing me up. Oh, threshold crossing height. My bad. So that's the altitude at which the pilot will cross the threshold of the runway. And that's where so when the pilot crosses over the top of the runway, that's telling you it's a 3% grade, like this 3% gradient. So he'll be coming down at 3%. As soon as he hits the end of the runway here, that threshold, he'll be 49 feet above the runway.
Oh, okay.
Does that make sense?
Yeah.
Yeah.
Man, good questions. Yeah, TCH, the reason why I was getting mixed up there for a second and why it sounded wrong all of a sudden as soon as I said it. TCH is Wasatch VOR. That's the identifier for Wasatch VOR. And this is the Ogden approach plate for Wolf approach.
The channel, so that's why I was confused.
So, any other questions? You guys are killing it. Like it. This also tells you that initial or that final descent into the runway is at 6,000 feet. So when they hit 6,000 feet, that's when they'll start that final descent into Ogden. I've shot this approach.
So with the line underneath the 8,600 and 600 or 6,000, doesn't that normally mean like 8,600 feet or greater? Not on this particular chart, because obviously you would overshoot it if you're at a higher height than that. But
right, that's just telling you this is where the approach starts. This part of the approach starts is at 8,600 feet, and this is where your final descent starts is at 6,000 feet.
Okay, because it says it has the same layout in the stars. Like it always has a line on top of the number or below the number.
Yeah. So, all right. So landing minimums. We've talked about this as well. So our aircraft are put into categories according to our approach speed. Okay. So depending on how fast we're coming into the runway, we have different minimums. The CRJ 700, we're in this C category. I believe our typical approach speed is going to be somewhere around 132 knots.
I feel like Category E is a way too big of an approach for fast.
Category E. So this is going to be your really heavy, your big, probably like your fighter jets, and then like your big cargo aircraft. So typically on most of the charts, you're just going to see an A, B, C, or D. But what you guys need to write down and remember is that our CRJ 700 that we're going to be using in this class is a Category C aircraft. So does everybody have that?
Mhm.
So this is where we go into the reading the minimums. So when we're looking at this chart, we're going to be looking at, so the SILS is standard ILS 3, standard localizer, right? And this is where, I think this is a NACO chart, which it's a little bit different than the Jeppesen chart. So the NACO chart, it's going to do the A, B, C, D categories across the top. And then what it's going to do is it's going to give us our ceiling down below with our visibility on top. So this is our RVR requirement. This is our visual and statute miles. No, that can't be a RVR. Huh. I will need to look at that. Oh. Yeah, that's not making sense. I don't use this type of chart. It's been a long time since I've actually looked at this type. Let's see if they've got the Jeppesen chart. Anyways, so this is your ceiling for sure. And this would be your, what is this number?
That would be the number to if you cannot see the runway or the airport, I believe, then that if you can't see it by that height, you have to make a missed approach.
No, that's your ceiling. That's this number here. So this is your decision height, 507 feet. But once again, we always round up, right? 601. I'm trying to remember what this number here in particular means. I'm going to have to talk to Adam and figure that one out. Once again, this isn't a chart that we use on a regular basis. This isn't the Jeppesen chart. And that's not how you guys will be seeing it. So this is landing under IFR conditions. So descent below the decision altitude, or MDA, minimum decision altitude. We have to have visibility. So if we're going to continue our approach into the runway, these are the things that we got to have. So we have to have visibility. We've got to be able to make a normal position to land. So we can't be like way off the runway, right? And then we have to have a visual reference for the runway. So if we're too far to the left or to the right, or too high or too low, then we'll need to go around. And then we have to have that visual reference of the runway. RVR not reported. We just got to convert the RVR reading to the statute miles, or convert, or vice versa, in order to determine our landing minimums. Greater than 2, raise the highest minimums table, and if the glide slope is inoperable. So we'll talk about that here in just a second. So this is the way that we see, like I was saying, this is not the way you guys will see it. This is the way that you guys will see it. We have our landing categories on the side here, have our RVR, and then our visibility requirement. So this is our RVR translates into our horizontal visibility, right? This is our decision altitude. So our decision altitude, that's what it is. Just clicked. Okay. Our decision altitude will be here. So this is what the pilot will read on his instrumentation, 4,980 feet. But AGL, above ground level, he will be 507 feet. Just remember. Sorry if you guys lost a little confidence in me there for a second. Okay, decision altitude, decision height. This is our visibility requirement.
You're fine. This is a lot to remember, I'm sure, for anyone.
Yeah, and when you're not used to seeing it in this form, when the only way you've seen it for the last long time has been in this form, you got to really, yeah, you've really got to go back onto your training, so and refresh that memory. So, anyways, let's talk about the approach lighting systems. So we call this an ALSIF 2, an ALSIF 1, a MALSR, that's that medium intensity approach lighting system, MALSIF, okay, RAIL, and ODALS. Okay, here's all of the acronyms broken down. So this is what the pilots have to be able to see in order to continue through the decision height and not go missed when they're coming in for a landing. They have to see this approach lighting system. As long as they see that, they can continue their approach. Does that make sense? Do you guys have any questions about these?
No, sir.
So the reason why they have different configurations is just depends on the runways and the airport that they're coming into. You're not going to see this at these smaller airports like, I don't know, even like Moab Airport or Bountiful Sky Park. You wouldn't see this elaborate of a lighting system because of the type of aircraft that are flying into the airport. So these are going to be your more like mainline, bigger airports. The hubs and stuff are going to have a lighting, an elaborate lighting system like this. But yeah, then it just gets more simple, just depending on the basically type of airport that you're going to be landing at. So
Which one does St. George have?
Well, heck, let's look. I can't remember off the top of my head.
I think it has the Odals, because if you're going to the airport from the Washington side, and you make that sharp left turn before going onto the freeway, you can kind of see the approach lights going in at night. And I think it looks like that.
Let's take a look and find out for sure. St. George Regional. All right. So we can look on the instrument approach plate, right? It'll tell us the lighting system. Let's see. It's not identified on this one. Or we can use the EFD.
Right? I think it is. It's the rail on
the rail
on.
So runway 1 has a rail lighting system. Runway 19 has a Mauser. Good question. I need to go back to that approach plate really quick. I wonder why, or if I just missed it.
It's on the bottom.
It's not there.
On the right side by the on the airport diagram on the bottom.
Oh, right here. So this airport diagram also will show you the type of lighting. So that's the Mauser right there. For some reason, it's not showing the rail. This P in a circle here, that stands for PAPI. So that shows the pilots using VFR. That gives them their glide slope so they can see how high or low they are above the runway, or if they're coming in on the glide slope. And you can also see that on the AFD. It says rail with PAPI and Mauser with PAPI. So rail, Mauser. Oh, Mauser right here. Not Mousif. Any other questions? You guys? Let's look at Salt Lake really quick while we're kind of having fun here. So once again, this is the same, kind of a more complex version of that same one you see in the corner. You can find that diagram there. This will tell us what lighting systems, once again, ALSIF 1 or ALSIF 2s, ALSIF 2s on those, and then 1.7 and 3.5 has Mausers. And then 1.4 and 3.2, they don't use a whole lot anymore. Pretty rare. But that just has a PAPI. So, and then going down to the approach chart for that, let's look at ILS going in on 16 left. There you go, right there. And then you can see those lighting systems, once again, looking at this diagram. Those are the two ALSIF 2s, and then these are your Mausers. Cool. Kind of fun to see what's going on at an airport, understand it a little bit. So, anyways, let's see, is there? That is a really jumbled, messy page. I don't understand what is trying to go on there. Landing minimum chart. So here's where we're going to dive into what that slide a couple slides ago was talking about. Okay, for straight in landings, and then we have our circle to land. Okay, straight in landings are going to give us our best minimums out of the two. Just kind of a side note, don't really think too much about it, but SkyWest's policy is our circle to lands cannot be lower than 1003. As you can see here, this is lower than 1000, but SkyWest policy says that we would have to round this up to 1000, and even though these are below 3 miles, we'd have to round that up to 3. But better minimums, again, with our straight-in landings. What kind of what category is the CRJ 700 again?
C.
Yeah. So, Charlie. So the way we would use this chart to determine our landing minimums is, remember that this is where we're going to find our decision height. That's the ceiling, required ceiling. What do we do with this number?
Round it up.
Yep, to the nearest 100, right?
800.
Yeah, so 800 would be our required ceiling for our minimums. And then we would come down here to our C category. And then right here, do you guys see this? So rail was that lighting system, right? Or ALS means approach lighting system. So if the rail or the approach lighting system is out, this is the visibility that we would require in order to or for our minimums. If all the lighting systems are working fine, this is our minimum. So our minimums, if everything's working fine, would be 800, a ceiling of 800 feet, and 1.5 miles of visibility. Does that make sense?
Yes.
Now, this box over here, you read these notes underneath your decision height. So this says with the local altimeter setting or approved weather service. Now, if you don't have the local altimeter setting, then these are the minimums that you have to use. So this is with the local altimeter setting, and this is without. Does that make sense?
Mm-hmm.
And yeah, so this just goes over the same stuff we've already gone over. So let's see. Just some referring to the 121, the FARs that we're pulling this information from, going through the airport's sketches that we went through. Let's see. There's a whole lot more here. Let me. We're coming up on the end of class here, so I'm gonna leave this here. I'll have Adam finish this slideshow off tomorrow for the airport charts. But what I wanted to do right now is we're going to apply some of those landing minimums here. So let's go back into SkyVector. I just want to make sure that you guys are understanding what we're talking about with landing minimums. So let's see. Someone name an airport.
Las Vegas.
Las Vegas? Okay, let's look at Las Vegas. So we talked about precision and non-precision approaches, right? Can anybody tell me the difference between a precision and a non-precision approach?
Precision has lateral and vertical.
Okay. And a non-precision?
Just has horizontal.
Okay. Okay. So what do you think is going to be more precise of a landing? What's going to have lower minimums?
I guess precision.
A non-precision, is that what you mean?
So what one's going to have
lower minimums is a precision approach, I would think.
Right. Because you're getting more information, and so it's more accurate information, right? And what are the two types of precision approaches that we talked about? I guess we didn't really talk about the one, but what are the two that we talked about?
I mean, like straight in and circle.
Or the ILS and RNAV?
Yep, perfect. ILS RNAV. So if we were to look at this group of charts, which one do you think is going to give us our lowest minimums?
2-6 left and 2-6 right.
Okay, so ILS or localizer, right? One of these charts. RNAV we don't use, so don't worry about those. And then VOR is a non-precision approach, right? So if we are looking for minimums, for our lowest possible minimums, we're going to go to our ILS. I want you guys to write this down. We would, if we're going to look for our lowest possible minimums, let's save ourselves the trouble of pulling up all 8 of these approach plates, and we'll just look at ILS approach plates because we want the lowest possible, right? We want to be able to get into this airport. So we're going to use the lowest possible minimums. So we'll pull these up, and what is the lowest possible minimums that we can have?
200.
And?
200 and a half mile.
Yeah. So 200 and a half mile are the lowest possible category 1 minimums that we can have. So make sure you guys have that written down as well. So ILS approaches are going to give us the lowest minimums, and the lowest possible minimums we can have are 200 and 1/2. So looking at this approach, this is telling us that we have 300 and 3/4, right, would be our minimums. And so we want to see if we can get down to that 200 and 1/2, right? So let's look here. Category C. The lowest possible we can get here. That is weird. I don't know why it says that. 100 and 3/4. It's not possible. That's interesting. Once again, these are kind of weird charts.
So I didn't get all of what you said. So he told us to write down this ILS approaches will give us the lowest, and then that's where I didn't get the rest.
Yeah, so ILS approaches are going to give us our lowest minimums. And then what you told us, the lowest possible minimums we can see on an ILS approach or on a Category 1 approach would be 200-foot ceilings and 1/2 mile visibility. Let's go to our JEP charts. I can read the JEP charts just fine. So pick an airport, any airport. Well, we already said Las Vegas. Let's go to the Las Vegas charts. Oops. So we'll come down here to our instrument approach plates. Okay. Here is our ILS for runway 1 left. Okay. Our height, our ceiling. Remember, we're Category C aircraft, so right here, our ceiling's going to be 284 feet. So what is that again? What are we going to round that to?
300.
Okay, 300 and how much of it is one? So 301. We're going to see if we can get down to that 200.5. Okay. Looking at this, what is this? Ceiling and visibility.
Can you zoom in a little more, please?
Yeah, sorry about that. So what are our minimums for this runway?
$303.25 miles.
Yep. Perfect. So we're still not quite there. So I think this is the last ILS approach. Let's look at this. It's our minimums.
303.25.
Okay. So the lowest minimums that we can get would be 303.25 at Las Vegas, right? For our landing minimums. Does that make sense to everybody? We can confirm that. We can come down to these charts and just confirm it. Remember what I was saying about non-precision approaches? So VOR, let's look at our VOR approach. What are our minimums if we go VOR for our Category C aircraft?
$101.75 miles.
What was that first number?
700.
Yep.
700.
Perfect. 700, 1 3/4. Okay. And then here's the VOR for the other runway. Once again, 700, 1 3/4. So our lowest possible minimums that we can get at Las Vegas, once again, are 300 3/4. Okay. So if I were to apply the one NavAid, say I wanted to make Las Vegas my alternate, and I was applying the one NavAid rule to this, what would my minimums be, my alternate minimums be?
Is it 502 miles?
Almost. So what do we got to add to our ceilings?
Oh.
For one NavAid?
Wouldn't it be 700 if you're rounding up to 300 on the minimums? Yeah.
Yeah. So you'd it would be 400 feet that we add to our ceiling, right? So we would round up to 300, and then we'd add our 400 to get a ceiling of an alternate minimum ceiling of 700 feet. And then our visibility, what do we have to add to that for one nav aid?
1 mile.
1 mile. So it'd be 1 3/4, right?
Uh-huh.
Okay, so our alternate minimums, if we're using the 1 nav aid rule for Las Vegas, would be 700, 1 3/4. Our landing minimums would be 300 3/4. So somebody else pick another airport. Hopefully we've got it. Another bigger airport.
JFK.
I don't see that on here. What about do a West Coast main hub or something?
San
Francisco.
Okay, San Francisco. I'll pull up San Francisco. So San Francisco, let's go see if we can figure out the minimums, the lowest minimums we can get for San Francisco. What approach plates am I going to go to first? You guys remember?
You're just ILS.
Yep.
ILS.
Yeah, so I'll look for my ILS approach charts. They're going to give me my lowest possible minimums. Okay. So looking at this, what would be my minimums for ILS to this runway?
300.
And?
It doesn't. I'm not sure because it's not. It just says 300. It doesn't say anything after that.
1?
Yeah, 301. So, once again, this is where we're going to get our ceiling. We're going to round this number up, right? Okay. And then we're going to go to our C category, and we're going to pull our visibility from that C category. Does everybody see that?
Yeah.
Okay. So, somebody else give me the minimums for this runway.
$201.5.
Great. So what are our lowest possible minimums that we can have for a Category 1 approach?
201.5.
Right. So this is the lowest possible minimums we can have for a Category 1 approach. So this would be the landing minimums we use to determine if we're legal to go or not. 201.5 mile visibility. Okay. Is that making sense to everybody?
Yes.
So I've got another runway here that has 200.5 mile visibility, so I could apply the 2 nav aid rule to this airport for my alternate landing minimums. So what would be my alternate landing minimums for this runway, or for this airport?
It's 401.
Perfect. Awesome. You guys are doing good. Does everybody understand that one?
Yes.
All right. Well, that pretty much wraps us up for tonight. How do you guys feel about it?
Feeling a little better. You shook my confidence earlier on that example.
I feel like the other charts are. I feel like the Jeppesen chart. Or is this Jeppesen?
This is the Jeppesen chart, yeah.
I feel like the other type of charts are easier to understand than these are.
Yeah, and that's what's great about these charts is you can, depending on who you're working for, I guess, you can use either one of the charts. WSI, we use the Jeppesen charts for SkyWest, but and that's just because that's who we get our WSI is who we use for our weather information. They're our approved weather source. So, and this is the chart system that they use. So,
yeah, these are just a little more harder to understand because I feel like these are in more complicating places than the other ones. But that's just my opinion.
Yeah. So yeah. Does anybody have any questions about anything that we went over?
No, sir.
No, but are those videos that were in the lesson plan, is that like homework for us to watch?
Yeah. So that's just going to give you a little, it's going to give you a refresher of the stuff that we've covered tonight. And so yeah, use those videos. Use those videos that are in this course outline to help you guys understand them. Maybe, it's always good to get multiple viewpoints when covering this material, but it just goes over the same information we've gone over tonight. So I highly recommend that you guys watch this one at the very least, the video about weather minimums and categories. So yeah, if you guys don't have any other questions, I'll let you go. Have a good weekend. I won't be on tomorrow, so
enjoy the jumpsuit.
Alrighty.
Thank you.
Yeah.
Thank you.